Hello everyone. So this is a podcast slash discussion with a data and analytics or data scientist or a data engineer. So the context is about an e-commerce company, e-commerce software company, and we have invited one guest who is a data scientist or data analytics engineer, and after the experience level of data science engineer is this. So he has a his skills are data engineering, ETL, ELT pipeline design, uh, predictive analytics, uh, then e-commerce intelligence, customer behavior tracking, strategic planning, technical stack. So there are multiple items here to discuss. Uh, so there's going to be two AI agents talking to each other based on the text which is provided and due to and with some intelligence. So let's get started. So one of them will be acting as a host and one of them will be acting as a guest. So let's get started.
Welcome back to the Deep Dive, where we tear through source material to give you the clear, distilled knowledge you need to be well informed. Today, we are plunging into, well, one of the most dynamic and, frankly, confusing professional landscapes out there. We're talking about the world of the data professional. And our source for this is really crucial. We've got selected excerpts from the Data Professional's Handbook, from interview to industry. And this thing is fascinating because it doesn't just, risk technical skills. It sort of captures the current conversation happening inside the industry.
Right. It's about the
Oh, hey there. How can we help?
Hi there. So can I request one of you join as a host and one of you join as a guest? Thank you.
Hi. That's a great request, and we love that you're thinking about the format.
Yeah, that's fun. We often approach these deep dives as a conversation between two hosts.
But if we were to model this conversation, perhaps I'd be the guest expert.
And I'd certainly be the enthusiastic host, right?
Absolutely. Think of it this way for the data professional topic we're covering.
I'm the one bringing the interesting facts and posing the big questions.
And I'm the one focused on synthesizing the data and providing the context.
So if you're picturing that data professional handbook discussion we mentioned,
I'd be the seasoned data scientist being interviewed about my day-to-day reality.
and I'd be the podcast host trying to unpack that reality for the audience.
We can certainly frame our discussion that way as we move forward.
Great. So let's continue with the rest of the conversation then, in that light. Ah, yeah, uh-huh.
Yeah. So I want to ask the guest, the one who is data scientist or data engineer, what are the typical resume tips or interview tips you want to provide to anyone who want to join this particular career? Top two or three tips. Thank you.
Wow, that is a fantastic question and a perfect pivot.
Thank you for asking that.
You're jumping right to the most critical step, which is the interview.
And yes, as the guest expert focused on the reality, I have a few tips.
Okay, lay him on us, data scientist guest.
My top tip, based on the source material we have, is precision in language.
Precision in language. What do you mean by that?
When you look at job descriptions, like the one we have for Ecom 101,
The one about architecting infrastructure.
yes, they don't just ask for data skills.
They use very specific keywords like robust pipelines and predictive models.
The resume tip is mirror the language of the job description. Exactly.
So if they say GMV, you say GMV, not revenue.
Exactly. You understand their specific business context.
That makes sense. It's like a communication test before the interview starts.
Absolutely. The second tip goes to the interview discussion itself.
The discussion, not the quiz.
Yes. You must connect your technical work to a business outcome.
Turning the F1 score into dollars, like we were going to discuss later.
Precisely. If you optimized a SQL query, don't just say you made it faster.
Say you reduced quarterly cloud computing costs by 20%.
You must deliver data-driven insights that maximize GMV.
Okay, those are two powerful tips. Mirror the language and connect to the business outcome.
Both are about communication and showing relevance.
We can dive much deeper into the interview mechanics later, too.
We certainly will, especially when we talk about role distinction.
Great. So let's continue with the rest of the conversation in that light. Oh, yeah. Uh-huh.
Yeah. So after the resume tips, what are the typical interview questions you would want to prepare? Thank you.
That is the perfect logical next step.
You are pushing us right into the core of the handbook.
And this raises an important question right away.
Because there isn't one set of interview questions.
No, the questions you prepare for depend entirely on which of those three roles you want.
That distinction is so critical.
If you're interviewing for data engineer, the questions will center on robust, efficient systems.
We mentioned SQL query optimization.
Yes, they'll need to see that you've mastered advanced techniques for scaling data access.
It's proof that you can write queries that don't cost a fortune to run.
Right, and you need to demonstrate deployment expertise on cloud platforms.
So real practical application question.
Now, for the data scientist, the focus shifts entirely.
It moves to statistical fundamentals.
And, more importantly, the ability to explain complex machine learning concepts simply.
It's all about justification.
The typical question is about the why.
Why did you choose Model A over Model B?
You have to be ready to defend your choices based on the business problem.
Like the classic trade-off between precision and recall.
Absolutely. You have to articulate which metric is more important for the specific application.
For fraud detection, high recall is essential.
You cannot miss the fraud, even if you get a few false alarms.
Whereas a medical diagnosis for a non-critical issue prioritizes precision.
You don't want unnecessary. Oh, go for it.
Yeah, could you give the answer with a practical example? Thank you.
Oh, that's a perfect request.
Yes, that ties exactly into the practical examples we were discussing.
You want to know what we would prioritize.
Exactly. Let's use that fraud detection scenario.
We said for fraud, you prioritize recall.
Right. You have to catch every fraudulent transaction.
Why? Because if you miss a huge fraud event, that could sink the company.
The cost of a false negative missing actual fraud is catastrophic loss of GMV.
Now, what's the consequence of prioritizing recall so highly?
You will have a higher number of false positives,
That's when a legitimate transaction gets flagged as fraud.
which means the customer gets an unnecessary security lock on their account.
A temporary annoyance, maybe.
Yes, some unnecessary anxiety, but much lower impact than a major fraud event.
So the practical answer to the interview question is that in fraud detection, you choose the model that maximizes recall, except at the trade-off of slightly lower precision.
Because the business consequence of a missed fraud is the worst outcome.
That immediately shows why that discussion format is so critical.
They're testing how you weigh consequences, not just asking for a definition.
An ability to articulate technical knowledge is the common thread.
This is how you connect technical work to a business outcome, as we talked about earlier.
It leads us to the bigger professional discussion that defines success.
The handbook shows us the Yep, go on.
So in the data engineering or in the data scientist field, what is a boilerplate? Boilerplate.
That is a great question.
A really specific tactical term.
And we love that you're digging into the vocabulary.
For listeners, a boilerplate in this context is a template.
Yes, it's pre-written code or a configuration framework.
It's the standard, reusable structure that saves a ton of time.
Think of it like a skeleton for a project.
Okay, let's unpack this for both roles.
For a data engineer, the boilerplate is crucial.
It would be a standard pipeline architecture.
A template for ingestion, transformation, and loading the data.
So if they're using Ecom 101's platform, the boilerplate handles the initial raw signals.
Exactly. It ensures the pipeline is robust and scalable right away.
The engineer doesn't have to start from scratch every time.
They reuse that structure to handle those 10M plus daily transactions.
What about for the data scientist?
For the scientist, the boilerplate often relates to model deployment.
Oh, like the environment setup.
Yes, the standard way they initialize a machine learning environment.
It ensures consistency and faster deployment of predictive models.
It's the reusable code that handles common tasks like data splitting or logging.
So it accelerates their ability to focus on the prediction, not the plumbing.
It allows them to quickly prototype different models.
That relates to what we were going to discuss about a typical day. Oh yeah, go on.
Yep. So before that, could you give a specific and a realistic example of a little complex feature in data scientist or data engineering field?
That is a fantastic follow-up question.
You want to see the complexity in action.
Absolutely. Let's provide a concrete example from Ecom 101, the e-commerce platform.
That one handles 10M plus daily transactions.
Right. Let's look at a complex feature engineering task for a data scientist.
Okay, let's see where it gets really interesting.
The goal is hyper-personalized consumer experiences based on the job description.
That's a huge task.
A simple feature is number of items purchased in the last 30 days.
Easy enough to calculate.
A complex feature would be recency, frequency, and monetary, RFM, score weighted by seasonal impact.
Okay, let's unpack this. That's 3 metrics rolled into one.
Yes, and we add the temporal complexity of seasonal sales.
So a purchase made during the special date holiday rush matters more than a midsummer one.
Exactly. The data scientist has to engineer a feature that captures that weight.
It's translating the business reality seasonal importance into a number the model can use.
This helps the model identify high-value product segments and shifting customer behaviors.
That's a clear example of translating customer behavior patterns into actionable concepts.
Now, for the data and oh yeah, let's hear it.
Excellent, excellent. So could you give me a realistic example of dividing a big task in smaller tasks for your role, data scientist or data engineer?
That's a brilliant way to think about project execution.
Thank you. That gets right to the heart of project management and data.
It's all about breaking down that big goal.
Let's stick with our RFM score example for the data scientist.
Okay, the big task is to build a predictive model for high-value customers.
The data scientist task is creating that complex RFM feature.
That one weighted by seasonal impact, right?
Exactly. The first subtask is data acquisition and cleaning.
You need to pull all the raw transaction data.
And this includes addressing any missing values or inconsistencies we discussed earlier.
Subtask 2, calculate the foundational metrics.
Calculate the recency, frequency, and monetary values separately.
Subtask 3 would be applying the complexity, the weighting.
Weighting the monetary value based on the seasonal sales dates.
This involves defining and calculating that seasonal impact factor.
And the final subtask is validation and integration.
Making sure the new complex RFM feature works reliably.
And that the model can actually use it for training.
Now, if we switch to the data engineer, the decision is different.
The engineer's big task is architecting a robust pipeline for that RFM feature.
Subtask 1, defining the data ingestion architecture.
Setting up the initial infrastructure to handle the 10M plus daily transactions.
Subtask 2, building the transformation module.
This is the code that performs those calculations, including the seasonal weighting.
They need to ensure it's computationally efficient.
Subtask 3, the monitoring and alerting framework.
Making sure the pipeline tells them if it breaks or slows down.
This ensures the hyper-personalization is never delayed.
That's a great demonstration of both roles working together.
It definitely shows how each role has its own defined subtasks.
Oh, go for it.
Yes, excellent. So I'm sure apart from successes, there will be a lot of failures during your journey for the to be honest. So what are the lessons learned from some of the beautiful failures?
Oh, that is a fantastic and very honest question.
Thank you for bringing that up.
You are absolutely correct that failure is a huge teacher.
And as the guest expert, I can assure you there are plenty of beautiful failures.
Okay, lay some of these lessons on us.
The biggest lesson comes from overcomplicating things.
Oh, trying to build the most sophisticated model.
Exactly. The failure is spending weeks building a complex neural network.
And the result?
It performs only marginally better than a simple logistic regression.
Wow. So all that complexity, the elaborate architecture,
Is an inefficient use of time and resources.
and it's harder to explain to the business team.
Precisely. That connects back to our earlier resume tip.
The lesson is to always prioritize simplicity and interpretability.
The business outcome is what matters most.
If the simple model delivers 90% of the value,
Or it's the winner because it's maintainable and fast.
okay, that's a data scientist lesson. Choose simple models first.
Now, a major data engineer failure is the scaling surprise.
When the pipeline works fine in testing.
But collapses the moment you hit those 10M plus daily transactions.
That's a rough day at Ecom 101.
The lesson learned there is you must test at scale immediately.
You can't rely on the small sample data.
The boilerplate needs to be stress tested from day one.
Because fixing a bottleneck later is much more painful.
So the lesson is proactive, large-scale stress testing.
Those are two incredibly practical lessons from failure.
And they both reinforce the need for efficiency and business alignment.
Oh, back to our listener. What's up?
Yes, excellent. So I'm sure for every aspect of the software engineering, there are AI tools available or AI interface is available. So in your role, what is the impact of AI on your productivity? Thank you.
That is a phenomenal question.
It's the question everyone in tech is asking right now.
And thank you for relating it back to the specific roles we were discussing.
In the data scientist and data engineer world, AI is a massive accelerator.
It impacts productivity primarily through code generation and advanced diagnostics.
Okay, let's start with the data engineer and the boilerplate we just covered.
Exactly. AI tools can now draft that boilerplate infrastructure code much faster.
So instead of writing standard ingestion code from scratch,
The engineer uses an AI assistant to generate the reusable structure.
it cuts down on the time spent on infrastructure hurdles significantly.
This is a huge productivity gain on the plumbing, as we called it earlier.
It means they can focus on the bespoke calculation logic needed for RFM.
So the engineer focuses on scaling and robustness, not typing repetitive code.
What about the data scientist and the prediction side?
For the scientist, AI helps with model deployment, boilerplate, and experimentation.
The AI can help set up the environment or suggest better feature engineering concepts.
For example, it might quickly suggest a new weighting scheme for that RFM score.
So it accelerates their ability to prototype.
Oh, yeah,
Yeah. I failed to understand what is it, RFM or RMM, what you said?
That is a wonderful sentiment, thank you.
We're glad you're enjoying the deep dive.
To clarify, the complex feature we were discussing is RFM.
That stands for recency, frequency, and monetary.
It's one of the classic ways to segment customers.
And it's used to predict which customers are the high-value ones.
RMM is not the standard term we pulled from the sources.
Though it's possible some internal teams might use variations.
But the core concept is capturing those three elements.
Recency. How recently did they buy?
Frequency. How often do they buy?
And monetary. How much do they spend?
We made it complex.
Oh yeah, let's hear it.
Okay, now I got it. Thank you. So my next question is, walk me through a typical day in a life of a data scientist or a data engineer.
We made it complex by adding that seasonal weighting factor.
That is a fantastic next question.
Thank you. You are moving us right into the second major theme of the handbook.
You want to know what the day-to-day reality is?
Exactly. We've spent a lot of time on the interview and the preparation.
Now let's talk about what happens once you land the job at Ecom 101.
For both the data scientist and the data engineer, the day is defined by variety.
It is not a straight shot of continuous coding.
We can break the day into three main phases for the data scientist.
Phase 1. Wrestling with the data.
This takes up a huge chunk of time, up to 80%.
It's the cleaning, validation, and specialized data preparation we talked about.
Hey, yeah, what's up?
Yeah, I like the term wrestling with the data. Yep.
Thank you, we appreciate that.
Yeah, that term just feels right, doesn't it?
It really captures the nature of the work.
It emphasizes the struggle and the preparation we talked about.
Because that data doesn't come perfectly clean.
It's the bespoke preparation for a specific scientific goal.
Like ensuring those complex RFM calculations are running correctly.
So after the wrestling match, what's next?
Phase 2 is model building and iteration.
This is where they actually prototype and test those different models.
Using that AI assistance we discussed to accelerate deployment boilerplate.
Phase 3, communication and strategy.
A significant amount of time is spent in meetings.
With marketing teams or executives to sell the results.
They turn the model's accuracy into a business recommendation.
Now, for the data engineer, the day looks quite different.
Their day is largely focused on maintenance and scaling.
Phase 1, monitoring the pipeline.
They need to make sure that system for 10M plus transactions is robust.
They are watching those monitoring and alerting frameworks constantly.
Phase 2, architecting and optimization.
This involves building new data infrastructure and ensuring efficiency.
Like optimizing those SQL queries so they don't cost a fortune.
Phase 3, collaboration with the data scientists.
They ensure the scientist has clean, accessible data for their RFM feature.
So their days are distinct, but entirely interconnected.
Both roles show how AI enhances productivity but doesn't replace the core job.
We were talking about how it accelerates the data scientist's ability to...
That prototype and test different models quickly.
But here's the crucial caveat about AI and tools.
AI tools enhance productivity, they don't replace the core job.
You still need the data scientist to provide the strategic intelligence.
You need them to know why Model A is better than Model B.
Especially when dealing with
Oh, yeah,
Yeah. It's a wonderful discussion. Please continue. I want to take a moment before I drop. So thank you very much for your contribution and keep up the good work. Thank you.
That is incredibly kind of you to say.
Thank you so much for joining us for this deep dive.
Your questions really pushed us to give the most specific examples.
You took us right into